I'm Alistair, I'm from NOWAT, and I'm here to talk about electricity measurement and how we can use that to manage electricity. So I'm going to talk about the tools that we use to measure electricity. I'm going to talk about a little bit about their history, what they measure. I'm going to talk about the resolution of these tools and why that's important. Then I'm going to talk about some of the applications, about how you might use it and the opportunities it affords. So let's go back to the beginning. When Edison invented the light bulb, that was just the start of the problem. The bigger problems were things like generating enough electricity for everyone, distributing that electricity over huge geographic areas, and probably not thought about very much, but probably more important than all of that was how do you bill for it? That's where the electricity meter came in. And the first meters that were out in the field were actually chemical devices. They used electrolysis to actually indicate how much consumption was being used on each individual premises. Of course, that wasn't very practical from a long-term point of view, so very soon these amazing devices like I've got pictured here came along. This is a particular favourite of mine. This actually uses a small shunt of the consumption of the premises to heat the mercury in these tubes here. When the mercury is heated and pushes across here and goes into this particular bowl, this bowl comes heavier, so it goes down, and that means that the contacts now starts to heat the mercury at this side and so forth. And every time the balance goes back and forth, it moves the little dials round. And in fact, by about the 1930s, all electricity meters were electromechanical of some type, and it wasn't until about 10 years ago that they started to be replaced with electronic ones. What I really should stress here is that all of these meters are designed to collect money. So the important things here are accuracy, standards, how much they cost. Most recently, can I remotely access the meter so I don't have to send a man out to read the dials? And when the electricity companies were split between distributors and generators, a lot of the distributors wanted more resolution about the consumption. They wanted to know like every 30 minutes what people consume so they could shop around different generators to buy it cheaper. But it was always for the supplier. What they measure is kilowatt hours, of course. I'm sure you know that, but kilowatt hours is the billing unit that you'll be charged for. That's the amount of energy used by a 1,000 watt load in an hour. So if you've got, say, 10 100 watt light bulbs and you run them for 1 hour, that consumes 1 kilowatt hour. Or if you've got one 100 watt bulb and you run that for 10 hours, equally that consumes 1 kilowatt hour. And that's what your supplier is interested in. It's always what your supplier is interested in that drives the meter he installs for you. The resolution, of course, is just the reading interval. And that's not really much of a when, is it? It could be any time this month or any time in the last 30 minutes. What it's crucially not telling you is it's not telling you how the electricity is being consumed. It's not got the resolution, even if it's got 30 minutes. You can't tell what's consuming it with that level of when. And it's not telling you where. It just shows the consumption for the whole building. So it might be your house or your office block or whatever, but it's not actually telling you whether it's in John's office or in the basement or in the pump room. It doesn't give you those two pieces of information, and if you don't have the when and where to enough resolution, you'll not be able to find the what. And ultimately, you need to know what's consuming the electricity if you're going to hope to manage it. But that's not important because remember, the electricity company were only interested in billing you. They weren't interested in telling you what was consuming it. So basically it's the right tool for the right job, and it's disingenuous to suggest something like a smart meter will ever be useful to you for actually doing energy management. Let me show you what I'm talking about. This is what Reading University's billing system shows. This allows the supplier to bill accurately and understand demand. Here's the chemistry building's electricity consumption over the course of the first 7 months of 2018. What does it tell you? On a daily breakdown, you can just about make out the day of the week, the weekends, using less of course, and the university breaks. On the sample of daily consumption, which is beneath that, you can see it's broken down by 30 minutes, and you can see the night time and the evenings consumption dropping off, maybe by about 33%. But it's pretty constant across the whole of the day, so why is that? It shows the consumption peaks around midday, just about after lunch, but again, it doesn't tell you why. And of course, that's just the chemistry building. What's using the power? I mean, and what's really important is, without knowing what, where and when, how do you know if that's what you should expect, whether that's right? No one sets out to answer these questions with better resolution and ability to compare consumption between loads. Here's the same building using NOWAT's monitoring technology. The same 7 months of consumption is broken down here by day, and if we zoom in on a single day, we see the similar distribution that we saw in the previous graph. The big difference with NOWAT system is though, we can go way beyond the 30-minute resolution. Let's look at the consumption at minute resolution. Now you can start to see the real pattern. It's not smooth like the 30-minute data, and we can zoom further to examine the pattern up close. Let's look over an hour. Of course, this is still the whole chemistry building, just like a billing meter. But now we can see the consumption such that we can see a pattern. Patterns are like fingerprints. They help us identify the load. A fridge looks very different to an oven, which is different to a PC, and so on. Of course, we still don't know where the load is, or if it's a combination of multiple loads. What if we could look at bits of the building, individual floors, areas, rooms and appliances? We know what you can. NOWAT can break down the chemistry building into individual loads. We've further broken down one of those loads, the research wing, into 9 subloads. And finally, we've broken one of those, the bus L, G and G load, into 3 further subloads. By looking at minute level consumption of the research wing, we can see that the pattern I showed you earlier is actually the same pattern we see on the research wing. And if we look further down, we can actually come down and look at a particular load in that research thing. Here I'm going to look at plant C in room LG69A, and in fact I can see that very same pattern. So this resolution has allowed me to actually find out where and what. It's the pump. You just don't get that, of course, with a billing meter. Let's look at the pattern now of a refrigerator. I've got 2 refrigerators in fact here. I've got one in blue and one in orange. In fact, they're the same refrigerator, but look at the difference in the pattern. The one in blue is actually using over 12 kilowatt hours per day. As you can see, it's on most of the time, while the one in orange is actually only using about 2 kilowatts a day, about a fifth. That's a saving between the two of them of about over £1,000 by today's prices. But being able to look at the signature tells me a lot about how the actual refrigerator is using energy. If you look at the orange one, you can see that the compressor, the big thing in the actual fridge, is going on and off. And of course, it will go on and off according to the temperature. When it goes on, it will cool the refrigerator such that it hits a bottom set point and the pump will go off, and so on. And that's great. But the blue refrigerator, that's using 5 times more electricity, that's only ever dipping off once every 6 hours, and in fact that's when the defrost heater comes on. So in fact it's running all the time, which tells me that it's never reaching temperature. So being able to actually see the pattern tells you a lot. Unfortunately, if I look at that refrigerator in the daily consumption that the billing supplier gives me, I have no idea. You just can't see that refrigerator in there. You can't see that it's broken. You can't see it's wasting £1,000 a year because it's hidden in 50, 60,000 kilowatt of consumption of the whole building. So now I want to actually look at how we can use that tool to maybe effectively save some energy, or at least identify where we might go about saving energy. I'm going to stick with the chemistry building because we've been talking about it earlier on, and I'm going to look at the consumption at various parts there. First thing we might want to do is actually look at the consumption during the night compared to the day. Is it good or is it bad? And this is a key thing, you know, about having a system like NOWAT. You can actually look at a particular building and then look at a very similar one to get a comparison. This particular building is using about 25% of the consumption, and that's for the whole of October here, during the night. And that's not so cool, because if you consider the night is 8 hours of the day, you know, the worst it could be, unless it uses more than that, would be 33%. So it's not actually saving a lot of energy during the night. And I think we saw that when we saw the distribution curve and the consumption. It's not good. How much electricity do we use during the weekend compared to the week? Again, is it good or bad? And in fact, it probably doesn't surprise you to see that it's pretty similar, 25–75%, because what it uses during the evening, it tends to use during the weekend. What consumes the most in the chemistry building? Now this is, again, quite unique to know what we can actually drill down, as I showed you before, look at individual appliances and actually compare those to other places, so we know if that's good or bad. Like in the fridge case I showed you earlier on. This is the breakdown. You should immediately be drawn to the fact that, you know, nearly 2/3 of the power is involved in heating and ventilation. And that's pretty amazing when you think that the chemistry building is heated by gas in this particular case. So this is really just moving air around. And what's significant about it is also that you can't do anything about it. It's no good turning lights off or changing anything in your control. This is purely something down to estates in the building. So if we were looking at energy saving strategies, we probably wouldn't want to spend a fortune trying to make you do something about it, because we've got to focus on this area. That's where the bulk is. You know, the 11% used in things like IT, even if we half that, we would only make a 5% difference. We've got a much bigger opportunity to focus on the big things. The 30% here is lighting and power. Now, technically you've got some control over that, turning off lights as you leave the room, but more easily reduced would be to make a decent lighting control. And I'll show you what I mean by this when we come back to in a minute. I talked about the whole of the chemistry building, is it good or bad during the month? Well, let's look at the strategies I want to talk about. Behaviour. Behaviour is by far the biggest, bad behaviour that is by far the biggest waste of energy in any organisation or in the home. But the problem is it's very difficult to change, because behaviour, people, they're changing all the time. If you take something like Reading University, you know, most of the undergraduate students don't stick around more than a few years. And that means if you're going to actually educate them to be energy efficient, you're going to have to spend a lot of money. Every year you've got a new cohort, you're going to have to spend money. And is that amount of money greater than the amount of energy you're going to save? Behaviour is a really tricky one. But these two are much easier. The maintenance, I showed you with that refrigerator. By being able to actually drill down to a particular appliance and compare that appliance to an identical appliance somewhere else, you can immediately see maintenance issues and do something about them. And that is a big win. And when I was talking about the lighting a minute ago, this comes under the settings. You know, equipment that you can automate is much easier to save energy with than anything else. That's a really easy win. So, for example, in the lighting, if we put movement detectors on the lighting, then the lighting will go off when the room's not in use. Big win. If we put thermostats that when somebody whops them up to some unreasonable temperature, reset themselves after a couple of hours, that's a big win. So settings and maintenance can be a really good way of actually saving energy. If I go on to the next slide here, you'll see something that I think surprises a lot of people. Behaviour actually accounts for around 2/3 of the energy waste. However, that third is quite easy to address, because it just means you actually maintain things and invest in the right automotive equipment to keep the settings in check. So this is really what we learn, that we can save energy. Now, let me show you how the tool works in the next video. I'll pull one apart. Okay, so I'll be back in a minute. And by the way, I didn't mention before, but if you have any questions about any of this, and because it's not live, you can always email me. My name's Alistair. It's ALLISTER @knowwhat.com. Okay, see you in a moment.